Okay, so I'm going to talk about 3D printing. 3D printing. It's like a regular printer, but in 3 dimensions. Isn't that amazing? So the types of 3D printing that you'd get at in a home printer, there's FFF, fused filament fabrication. I think someone just came up with that because they wanted 3 Fs. It is actually the exact same thing as fused deposition modeling, which is another fancy term for it. It's basically just spitting out plastic onto a surface. It's like whatever material you have, it just goes around and spits it out there, and those layers get fused up into an actual thing. So there's 2 types. There's Cartesian and delta. It's like Cartesian is just like, X, Y, Z, exactly like you're doing on a piece of graph paper. And then there's the delta, which is, it's got 3 arms, and it uses polar coordinates. I actually got a picture of it right here, which is kind of neat. Yeah, it's crazy. Like you can get them really, really tall. The actual the width of them isn't so great, or it's not any bigger than a regular printer. But because they're just riding on those rails, you can make like really, really tall things. The resolution of them is really good near the center, and as you get further and further out, it starts to get a little worse. It can't get as precise because of the way polar coordinates work. But this is too big. That is Cartesian. That in particular is a PrinterBot LC, which you would be able to see, except that's cut off there. That's more or less the same model as what I have. And it just goes, X, Y, and Z to layer things out. There's also stereolithography, which instead of spitting out plastic, it's like a vat of either powder or a liquid material, and it uses the intersection of lasers to heat up or do something, presumably heat up, or it just uses, it gets X-rays, and no, X-rays are bad. But anyway, it has every individual spot fused into whatever you're trying to do on that particular layer. Because it's using layers and not spitting out plastic, it can get really, really fine resolution, and the stuff that it puts out can be really good. But the powder and liquid are not. They're a lot harder to work with, and they're kind of they can be a lot more toxic. So it's not really something that home printers have. Home printers are FDM because the materials are safer, which are like this: thermoplastics, PLA and ABS. They just come in big spools of basically whatever color you want, and they melt at a certain temperature. In the case of PLA, it's anywhere between 170 and 210, and ABS is 210 to 250, and that's Celsius. That's not Fahrenheit. So they're not just going to melt on you randomly. PLA is a little more fragile. It's plant-based. It's technically biodegradable. It's still over decades versus millennia. But it's a little bit more fragile than ABS. But the thing is, ABS, when it melts, gets this really bad aroma that gives me and my wife headaches, so I don't use it. But there's also wood and stone. They're actually it's wood with PLA. It's I think it's 40% wood, 60% PLA, but it makes a really nice finish, and it actually looks like wood, feels like wood. They have a stone version of the same thing. I've seen people print with clay. There are printers that will print in concrete, and as Prem mentioned in Campfire the past couple of days, there's actually an ice cream printer. There are printers that will print frosting, like a big bag on top of the basically the same kind of printer as I have, and it will squeeze out frosting and predefined shapes. It's pretty cool. And you know, you can print in human cells. I mean, well, let's be honest, you can't, I can't, but people are printing with human cells. This is actually the ice cream printer. We don't actually need sound. So you can see it's going around in this case, a star. And I believe this has like liquid nitrogen pouring onto it to make sure everything stays, you know, nice and frozen. But I guess it's not doing that great job on the bottom. But you know, it. Oops. But the way it prints, it just follows the thing, goes up a layer, follows it again, and you know, with a bunch of liquid nitrogen on it, it's bound to stay frozen at least a little bit. This is sugar, which is just amazing. I don't actually know the process used in this, but I would be surprised if it wasn't just like an FDM process. But like the curves of that are incredibly smooth. And normally on a 3D printed thing, you'd get like, you'd be able to see the layers more easily, but it didn't really happen with this. Yeah, like they can print some very impressive sugar things, which is.
Is it an egg white binder? Or
I have no idea.
Yeah, egg whites can be really sturdy.
That's the crazy thing. The home printers that you can get are all like 90% based on the RepRap project. And the RepRap project, its idea is to make a printer that can print a printer. And aside from things like the rails that, you know, the carriages have to slide on, and the actual extruder, which has to heat up, it actually quite a lot of, and the electronics, quite a lot of it can be printed. But it's usually cheaper to like print the fittings and the clamps and stuff, and like leave like the rods and the large surface areas that, you know, for like you saw in the PrinterBot LC, it was laser cut. That's why it's called LC. So the larger areas of just holding it together are wood, but you could print it if you wanted to. So the process of actually printing something, you take a 3D model, you cut it up into thin layers, you print a layer on top, like each layer on top of each another, and then you have a thing. It's actually, you know, it's really simple. It actually is like, you know, a sheet of paper, printing it out and putting another sheet of paper on top, print something on that, put a sheet of paper, print something on that, except that you'd have to do a lot of cutting if you were going to print it with a regular printer. So this is, I don't know if you can really see that well. This is this is GitHub's STL Viewer, and so it's this is the file format that is used for making the 3D models. This one in particular is the model of Winterfell from the Game of Thrones intro. So if you really wanted to, you could print your own Winterfell, which is fantastic.
Why haven't you? Because
this is the actual size of it is about this big, and my printer's not that good. I could not print this. So basically, you take that model, which is on GitHub, you can get for free. It's on my account. Same thing with the Ralph that I had on the blog post, and you slice it like you run that through a program that will take that and do all the physical calculations of you know, the width of the nozzle on your extruder, the amount of plastic it will extrude for any period of time, and just go through and like the entire thing and however many slices it takes, and make those instructions that it can send to the printer.
It also seems to optimize the path, because it doesn't just go straight back and forth.
Sometimes it optimizes it. Sometimes it makes some decisions that will baffle you, which is why they're really fun to watch. Actually, we can see it right here. So this is actually a MakerBot, but it's really you can really see how it builds it up. So we get the outer layer is just, it's going to be what you actually see, and then this is the stuff in the middle here is the infill. So it basically, in order to support things higher up, you get the infill so that it doesn't just fall back in, and so it just builds it up layer by layer. This printer in particular, the extruder slides around on the X and Y direction, and the Z actually goes down, like the bottom falls away. Like on mine, the carriage goes up and the bed the carriage moves left and right, the bed moves backwards and forwards, and the Z goes up and down. But you can see that it can actually turn out some pretty good prints. And if you look right here, you can see. If you look like on the lips here, you can see the actual layers themselves. They're usually fairly prominent. Yeah, actually, you can see them a lot right there. But the thinner the layer you get, the less you'll be able to notice that. So if you wanted to get into printing yourself, there's a couple printers that are good that you would that will print out, or that'll turn out good prints and are relatively cheap. The PrinterBot Simple is basically the cheapest one you can get that will still be good, and in some cases it's the cheapest one you can get. The LulzBot LulzBot has a really good reputation, but it's a really expensive printer. The Maker Farm Prusa is another. It's a kit, you put it together. The Ultimaker comes all assembled, but again, Ultimaker has a really good reputation in the space. If you do buy one, please don't buy a MakerBot, and I'll tell you why later, but I don't want to, because it'll take too long. The PrinterBot Simple, you can get the Maker Kit version for $350. You get to assemble it. You will know everything about that, about how how everything's put together. Everything you needed to tweak in order to get it there. It's actually really good for knowing what you're doing after it's done. However, if you want to pay for a super nice one, you get the benefit of it actually working, because there's a pretty good chance that it won't work right off the bat. Because even the really good kits, you put them together, and because you put it together and you don't necessarily know what you're doing, it can be kind of wonky. The super nice ones, like I think the LulzBot is like 1900 or something assembled, but it's really good. The Ultimaker was like, I think 1300. But you can get some really, really nice ones with like multiple extruders, so you can print in different colors. But yeah, those will actually work. They're always tested before they're shipped to you. And the best part about a 3D printer, and what everybody loves doing, is you get to print your own upgrades. So say you wanted like a different fan shroud to cool off the filament as you're printing it. You can print one of those and then attach it, and then like, oh look, now my prints are even better. Or you can like a different coupling from the Z motors to the threaded rods that raise and lower things. It's like, oh, now they're working even better. It's great. Basically, I would say probably at least half the things on Thingiverse, which is just a repository of models that you can print. At least half of that is upgrades to existing printers.
What's the difference in quality between a $250 printer and a $2,500 printer?
It's pretty big, and like there are people who have taken some of the lower cost printers, like the PrinterBot LCs, like I have, and there was a guy who tweaked the hell out of it and put a really small nozzle and could print incredibly tiny things with really good resolution. So it kind of depends on how much work you want to put into it too. Just putting it together, like the PrinterBot simples are actually pretty decent. They're not amazing. You won't get like super fine resolution. Like the 2mm layer height and the Yoda head that we saw, you probably wouldn't get that good looking a Yoda head out of it. The $2,500 ones, you might get that on your first print. Yeah.
How much is like the material? I mean, are they
The material
do they get expensive?
The material is relatively cheap. What's annoying is that it takes filament instead of pellets. Like, and the filament is like 5 times more expensive than the pellets. Like
Whatever company would that do that build a cheap way to create filament from pellets?
I don't know. I haven't heard anything about it, so I'm not really sure it's taken off.
Kickstarter and-
Yeah.
Oh, interesting.
But yeah, like I think like 5 pounds or a kilogram, I forget exactly, would be like $35. It's not super cheap, but it's not super expensive. It's, in that range of like, well, I'm already in this hobby, so it's not that bad.
Ink.
That's true. It is. It is actually cheaper than ink. Yeah. So if you wanted to check out more about this, Reddit.com, our functional print, has things that are actually useful. Like it was made as a showcase for things that people print that actually have a use rather than just more upgrades to your printer, which are fun. Or like Yoda heads. You're not going to find Yoda heads on there because they don't do anything. The RepRap forums are good. The Reddit 3D printing and the Google Plus 3D printing communities are actually pretty good. But that also means you have to use Google Plus, which whatever.
What kind of software interface is it, or standard piece
Yeah.
of software that everybody prints from?
It is pretty standard. There's like the actual like machine code of a printer is called G-code. I think it was originally made for like routers, to CNC routers to control where things are going. But they figured it can work just as well for printers. And so all the slicers will output G-code. There's like some different flavors of it for different firmwares, different hardware that you can get, but it's basically standard. I actually have my Raspberry Pi hooked up to my printer so that I don't have to like connect my computer to do the printing. I can operate it wirelessly and let the Pi handle the communication, because the printer itself doesn't it doesn't have like a buffer or a command interface or anything. It's just like you're just talking to it basically constantly. So I let the Pi handle that, and it's even that the website that it's running on the Pi that is the UI for that communication. It works fine. Like you just send the G code and then
MakerBot prints off an SD card though, even though there's
yeah, I mean like I can print off an SD card,
okay.
but it's more of a hassle because you have to take out the SD card, bring it over to your computer, switch things out, bring it back, plug it back in.
Oh, but I just mean the MakerBot right off the SD card, because I guess they have the printer software built into it.
Yeah, but I mean you have to get the files onto that SD card somehow. That's basically all I do.
I'm just saying you don't need an attached computer. Sorry.
Yeah. Yeah, there are ways to do it. This way it just happens. Like the Raspberry Pi just happens to work pretty well for me. There we go.